Let's discuss about the roots of a quadratic equations. What exactly are the roots? Actually, the roots in over the x values when the equation is 0. The roots of any quadratic equation ax squared plus bx plus c is equals to 0. They can be found by using the formula x is equals to minus b plus or minus b squared minus 4ac all divided by 2a. O ka kgona go lemoga gore actually the roots in over the x values, in over the x intercepts, because ge re šomiša this equation ke ge re nyaka go find the x values. So what is important again is to understand gore the roots of quadratic equation can be in different ways. Let's see. Those roots can be real or non-real. And then they can also be rational or irrational. Remember gore ge re bolela ka real re no bolela ka any existing number. So ge o ka re o solve that equation and then ya fa any number ile gore ya exista, then re la gore you are having the real. But what if o fa a number ile gore doesn't exist, re la gore o tla ba o na le a non-real. Let's say for example you find something like this one. Ge o ka re o try go press a calculator, you will realize gore e tlo fa error, e fa undefined. So any number ile gore ka gare ga a square root and then that number it's negative, e rela gore re na le a non-real. And then what about rational? Remember gore rational re no bolela ka any number ile gore it can be written in the form of a over b, whereby a and b are all integers. All terminating decimals are rational numbers. Let's say for example we have something like 2,5. Because this decimal ya felela re la gore o na le a rational number, because this number can be written in the form of a fraction. And then remember gore irrational re no bolela ka any number that cannot be written in the form of a over b. Actually rational number ke opposite ya rational number. Let's say for example re na le equation e re x squared plus 3x plus 4 equal to 0. And then the question is discuss the nature of the roots. Re nyaka go tseba gore re na le real, non-real, rational, irrational, equal or unequal. So re tlo šomiša this formula. Remember gore mo coefficient ke 1, re la gore a ke 1 and then b ke 3 and then c ke 4. So re la gore ke tlo re x is equals to minus b plus or minus b squared minus 4ac all divided by 2a, and then from there ke substitute ke na le minus 3 plus or minus b squared minus 4a and then c ke 4, then divide by 2a. Our a is 1 by the way. And then ge o ka re o pressa this part ka calculator ka fela yona, you will realize gore o fa negative 7. So re na le negative 3 plus or minus negative 7 over 2. And then ge o ka re o try go pressa this part ka fela on your calculator, you will realize gore it will fa undefined. Why of undefined? This is because more than a negative root. So in conclusion, more the type of the nature of the root a non-real. Why a non-real? Because our x value here o ka kgona bona gore it doesn't exist, but ke nyaka gore o lemoge something. O ka kgona bona gore the part ya o dira gore re be le non-real, the one ya o dira gore re be le undefined, ke this part ya -7. So this part ya -7, remember gore re kry-ile re substitute ka these values, and then this part ke this one, b squared minus 4ac, ke yona re file go -7. So this part ya b squared minus 4ac ke yona ya determine the type of the nature of the root, because re file gore ke -7. So what you should know now gore the part ye le gore it determine the nature of the root ke this part ya b squared minus 4ac. This part re bitša gore ke the discriminant, re represent ka delta. So in future re tlo ba re šomiša this formula, which is the discriminant, ke yona e determinago the nature of the root, because now o ka kgona bona gore our delta it was negative. So because delta ya rena e re file negative, and then the type of the nature of the root re kry-ile gore ke non-real. So this part is very important, re tlo ba re šomiša yona in future. So let's see our next example. And then what about this one? X squared minus 6x plus 9 equals to 0. More our a is 1, and then our b is -6, and then our c is 9. So let's use the equation. X is equal to minus b plus or minus b squared minus 4ac all divided by 2a. And then now let's substitute. Our b, it's -6, so re na le negative, and then -6 plus or minus, and then b squared minus 4, and then a it's 1, and then c is 9, all divided by 2a. 2 times 1. So more probably negative times negative is +6, so re na le 6 plus or minus, and then ge o ka re o pressa calculator this part you fa 0, so re la gore mo re na le 0, and then divide by 2. So mo ge re tšwela pele re tlo re x equal to 6 plus 0 over 2, or x equal to 6 minus 0 over 2. Remember gore square root sa 0 e no ba 0, and then because mo re na le plus or minus re la gore re a separate gore kgone go kry-a different answers. So ke 6 plus ke plus, and then ra ba le 6 minus ke this minus, and then this 0 ke this one. So from there re la gore re ba le 6 plus 0 over 2, and then re fa 3, and then this one re fa 6 minus 0 over 2, le yona re fa 3. So ke nyaka gore o lemoge something now. Mo discriminant ya rena this part re file gore ke 0. So in conclusion ge re nyaka go determine the nature of the root, re tlo re na le real, and then re tlo re rational, and then ra re equal. The reason re it's real is because 3 is existing number, ya exist. Ra tseba gore all existing numbers are real numbers. And then here we are saying it's rational. The reason we are saying it's rational is because 3 is a rational number. Remember already 3 is a natural number. And then that's about all natural numbers are rational numbers. And then here we are saying equal, because ka kgona bona gore re kry-ile two solutions kaofela ga tsona ke 3, they are equal. So in conclusion re la gore if our delta e lekana le 0 re la gore the type of the nature of the root re tlo re na le real, rational and equal. So it's important again to write this one down. And then let's see this one. Let's say on a x squared minus 5x minus 6 equal to 0. And then more our a is 1, and then our b it's minus 5, and then our c is minus 6. So ordinarily x equal to minus b plus or minus b squared minus 4ac divided by 2a. So let's substitute. Ordinarily negative 5 plus or minus, and then minus 5 squared minus 4a, a it's 1, and then c it's negative 6 divided by 2 times 1. So negative times negative is for positive, so only 5 plus or minus, and then that part ka fela yona o ka re o try we press a calculator it will for 49, and then divide by 2. So let's see now or what is our answer. So re la gore x equal to 5 plus square root of 49 is 7, so re na le 5 plus 7 over 2, or x equal to 5 minus 7 over 2. Remember or re na le plus or minus, that is why I'm at 5 plus 7 is square root of 49, and then this minus key this one from the formula. So from there 5 plus 7 divided by 2 is for positive 6, and then this one 5 minus 7 divided by 2 is for negative 1. So our solutions are greatly x is equals to 6, and then x is equals to negative 1. So let's see what is the conclusion. Our conclusion is real, and then rational, and then unequal. So the reason we are saying it's real, 6 and negative 1 are all existing numbers, so they exist these numbers, and then rational. Why are we saying rational? Because it's about all natural numbers, and then all integers, all whole numbers are rational numbers. So 6 and negative 1 can feel like the rational numbers, and then also they can be written in the form of a fraction. So that is why they are all rational numbers. And then lastly, morally unequal. The reason we are saying unequal because on our solutions really two different answers, or I can say really the answer x selekan. So x is 6, and then the other one is negative 1. So that is why we are saying it's unequal, because 6 really negative 1. So this is our conclusion. So now if the discriminant b squared minus 4ac really it's greater than 0, because o ka kgona bona gore e re file 49, and then 49 is greater than 0, meaning it's positive. And then another thing that is very important ko lemoga gore 49 is a perfect square. So ge le gore re na le delta that is greater than 0, and then also yaba a perfect square, re la gore re tlo ba le the type of this nature. It's real, it's rational and unequal. So note this information down, or if the discriminant is greater than 0 and then a perfect square, re la gore re na le this type of nature of the root. So a re lebelele the next one. Let's say re na le 2x squared and then plus 3x minus 7 equal to 0. Our a for this case it's 2, and then b is 3, and then c is minus 7. So re na le x equal to minus b plus or minus b squared minus 4ac divided by 2a. Then let's substitute. B is positive 3, so re na le minus 3 plus or minus, and then b is 3 minus 4, and then a is 2, and then c it's negative 7, and then 2, and then a is 2. So re na le minus 3 plus or minus. Ge o ka re pressa this part kaofela on your calculator, it will fa 65. So more re na le 65, and then divide by 4. 2 times 2 is 4. So from here it means re na le x equal to minus 3 plus root 65, and then over 4, because kwa lemoga gore 65 ga se perfect square. So ga ka re press a calculator it will fa root 65. So that is why ke ne ngwala the way lo ka gona. And then or x equal to minus 3 minus ke this one, and then root 65 over 4. And then o ka ro pressa this part ka calculator, it will offer something like this one, because o ka kgona lemoga gore this number ga se perfect square. So e rela gore from there ke tlo share into decimals, and then ge ke share into decimals, this one in for 1,265 and then other numbers, and then this one in for negative 2,765, negative 2,765 and other numbers. So now let's make the conclusion. So making the conclusion, re na le real, and then re na le irrational, and then re na le unequal. So this is the nature of the root. Why are we saying it's real? It's real because these numbers kaofela dia exist. So these are the existing numbers. And then why are we saying it's irrational? It's irrational because o ka kgona bona gore 1,265 it's irrational. Remember, irrational ke opposite ya rational. Irrational re tseba gore e na le non-terminating decimals. O ka kgona bona gore this decimal ga e felele, unlike o na le something like 1,5. So this is a non-terminating decimal, and then o ka kgona bona gore it doesn't have a pattern. Let's say o bona le 2,53, 53, 53 and so forth. So e be tla ba rational, but this is not the case. So re la gore this is irrational. And then the reason e le unequal, it's because 1,265 ga e lekane le negative 765. So re la gore this is the conclusion ya the nature of the root. So what is important, o ka kgona lemoga gore our discriminant, this part, e re file gore ke 65, which is a positive number. So discriminant is positive, and then also this discriminant o ka kgona lemoga gore it's not a perfect square. And then for the reason ya gore our discriminant ke positive and then ga se perfect square, re la gore the nature of the root it will be real, irrational and unequal. But ge o ka checka the previous one, o ka kgona lemoga gore re be re na le 49. So 49 ke positive, and then at the same time it's a perfect square. So ge le gore discriminant ya rena is positive and then is a perfect square, re be re ba le real and then re ba le rational. But this one, because ga se perfect square, e re la gore re ba le irrational. So this information is very important. O tlo tshwanela gore o ngwale everything down, and then re tlo focus on practice problems mo e le gore we are not going to use this formula, but tla be re šomiša the discriminant. So let's make the summary ya everything. And then here is our summary. This is the discriminant, and then mo ke the type of the roots. And then more, if delta is less than 0, meaning it's negative, re ba le non-real. And then the moment the delta e ka ba positive, re ba le real. But let's say this delta is positive, and then at the same time yaba a perfect square, re ba le real, rational, and unequal. And then ge it's positive but it's not a perfect square, re ba le real, irrational, and unequal. So ge delta e lekana le 0, if you remember, re ba le real, ra ba le rational, and then ra ba le equal. So this is our summary. So now let's check the questions and then re šomiše the discriminant. So let's see these examples. This question area, without solving each of the following equations, discuss the nature of the roots. So it means ra tshwanela gore re šomiše quadratic formula, because here without solving each of the following equations. So it means re tlo šomiša the discriminant. So a re lebelele part A first. Mo ka kgona bona gore the value ya A ke 1, and then ya B it's also 1, and then ya C it's also 1. As you can see, A here is 1, and then B ke 1, and then C is also 1. So re tlo šomiša the discriminant. The discriminant area, B squared minus 4AC, and then from there a substitute. So our B is 1, and then our A is also 1, and then our C is also 1. So it will fa this is 1, and then minus 4, and then it's negative 3. So our discriminant, it's negative. So what is the conclusion? If discriminant is less than 0, the nature of the root is non-real. So the reason it's non-real, it's because the discriminant is less than 0. So this is the answer for part A. Are lebelele part B. For part B, the first step re tlo tshwanela gore re beye equation ya rena in the standard form, because re tseba gore the roots are the x values when the equation is 0. So re tlo beya this equation in the standard form. So this is x squared equal to 2 at x plus 1. Ke tlo re 2 times x, and then 2x, and then 2 times 1 is positive 2. And then from there, can you make sure your one side ever 0? So this is x squared minus 2x minus 2 equal to 0. So from there, A it's 1, and then B it's minus 2, and then C is also minus 2. So from there, ngashumisha the discriminant. Okay, B squared minus 4AC. So now let's substitute. B squared minus 4, and then A is 1, and then C it's negative 2, and then the answer of positive 12. Okay, press a calculator, it will positive 12. So now let's make the conclusion. So erela or more real and then renally irrational and then unequal. The reason is because the delta is greater than 0, and then at the same time the delta is not a perfect square. So this is the reason, because 12 is not a perfect square. So if you're not sure, we can calculator wa 12, and then you'll realize a natural number or a whole number. It's not a perfect square. So this is the conclusion for this problem. Delta is positive, and then at the same time it's not a perfect square. So the type of the roots it will be real, irrational, and unequal. Part C. So for part C, we will do the same thing. We will try we are in the standard form. Renale x squared equal to 4x. So kutuja 4x ya jamba equal sign, and then kabale x squared minus 4x, and then washala wale 0. So it means A is 1 because more renale 1, and then B it's minus 4. That's where B is this one, and then C is 0 because there is no number here. So now let's use the discriminant. B squared minus 4AC, and then let's substitute B squared minus 4, and then A, and then C is 0. So the answer is positive 16. So in conclusion, the type of the roots are real and then rational and then unequal. This is because delta is greater than 0, and then at the same time the delta is a perfect square. Because 16 is a perfect square. So this is the conclusion. Part D is already in the standard form. So A it's negative 2, and then B it's negative 16, and then C it's negative 32. So using the discriminant, B squared minus 4AC, and then from there B it's negative 16 minus 4, and then A it's negative 2, and then C it's negative 32. So the answer that we get is 0. So the nature of the root real and then rational and then equal. The reason is because delta is equals to 0. So that is the only reason. So what is important is to remember delta is greater than 0, less than 0, what type of roots. So this is our answer anyway. Another examples, and then this one show that the roots of the equation are real, rational, and unequal if m is not equal to 0. So step number 1, let's make sure ya gore re ngwala this equation in the standard form. So re na le x and then 6x minus 7m equal to 5m squared. So ke tlo multiply out a bracket. So x times 6x e re fa 6x squared, and then x times 7m e re fa minus 7mx, and then ke tlo tšea 5m squared ka transpose to the left hand side, and then ya ba negative, and then ka ba le minus 5m squared, and then equal to 0. And then from there, what is important is to see the value of a is 6, and then the value of b is minus 7, and then the value of c is minus 5m squared. Remember re na le equation ya ax squared plus bx plus c. Re tseba gore the value ya a ke coefficient ya x squared, so more coefficient ya x squared o ka kgona bona gore ke a, so it means here it will be 6. And then re tseba gore b ke coefficient ya x, so if this is x re la gore this is b, and then mo ka kgona bona gore this is our x, re la gore b must be this one. And then re tseba gore c ga e tshware anything ya ba le x, so ka kgona bona gore this is just c ga ine x. So we can say a is 6, and then b it's minus 7m, and then c is minus 5m squared. Then now let's use the discriminant. That's our delta equal to b squared minus 4ac. So our b is minus 7m, and then minus 4, and then a it's 6, and then c is minus 5m squared. So from there, this one is for 49m squared, because minus 7 squared is 49, and then m squared is m squared. And then this part of yona is for positive 120, because negative 4 times 6 times negative 5 it will for positive 120, and then more than m squared, so re la gore m squared. Then ka kgona bona gore these are the like terms, so re la gore ke tlo re 49m squared plus 120 squared, re la gore em fa 169 squared, I mean 169m squared. So this is our delta. So ka kgona bona gore this delta is greater than 0, and then at the same time is a perfect square, because 169 is a perfect square, and then also m squared is a perfect square, because ge o ka beela 169 ka gare ga square root ya o fa 13, so 13 is a natural number, and then ge o ka beela m squared ka gare ga root ya o fa m, so re la gore this is a perfect square. So because delta is greater than 0, and then also delta is a perfect square, re la gore prove gore these roots are real, rational, and unequal. Remember ba rile m is not 0, because ba tseba gore if m e ka ba 0 re la gore everything here will be 0. So this is our answer anyway. This one show that the roots 3x squared plus 8k plus 2 x is equals to 1 minus k are real, rational for all values of k. So what is important to go this is a rational. Let's say if it's a rational, expect our our delta be greater than 0, and then at the same time be perfect square. So that is a key thing. So what is important from here, get over this equation in the standard form. So marginally 3x squared, and then plus k plus 2, and then x. So go to 1 minus k transpose, and then 1 more globally -1, and the negative k yava positive k. So rashala 0. What is important here is to notice the value of a is 3, and then the value of b is k plus 2, because b is coefficient ya x, and then c is everything ya go x. So I can say a is positive 3, and then b it's k plus 2, and then c it's -1 plus k. So now I can use the discriminant. I'll say this is b squared minus 4ac. So from there I can substitute. So b it's k plus 2, and then all squared minus 4, and then a is 3, and then c it's -1 plus k. So from there it's all about simplifying. So this one irfa k squared plus 4k plus 4. If you're not sure, remember more it's only 2 brackets, only k plus 2, and then k plus 2. Therefore we'll multiply out the brackets over k times k of k squared, and then k times 2 of 2k, and then 2 times k of 2k, and then 2 times 2 of 4, and then add like times 2k plus 2k of 4k, and then is the same thing. And then from there, -4 times 3, this is -12, and then morally -1 plus k. So this is the same as saying k squared plus 4k plus 4, and then now we're going to multiply out brackets. So this one times this one here for positive 12, and then this one here for negative 12k. So from there we are in the standard form, group like terms. So k squared it's a maya alone, and then marginally 4k minus 12k. So 4 minus 12 minus 8k, and then morally 4 plus 12, and then 4 plus 12 for 16. So marginally 16. But lemga something, what we know at some point we expect our really like the like terms are add everything, but this is not the case. But actually this problem is quadratic, so in the form of a binomial. So this problem as k minus 4 and then all squared. Remember if this is a quadratic, k squared minus 8k plus 16. So if this is k squared minus 8k plus 16, this problem okay factorize over 2 brackets, and then more over k minus 4, and then even here over k minus 4. So because it's k minus 4 2 times, so in this way, and then yawa squared. So now in conclusion, this part we did square root. Actually this part is a perfect square. So prove this is indeed real and rational. Remember gore any number you lo ka kgona go bea ka raga square root, so e rela gore it's a perfect square, because here ge nka bea square root e rela gore this root you cancel this 2, so e rela gore this is a perfect square. So in this way re provile gore this is rational, because o ka kgona go bona gore delta is greater than 0 and then also is a perfect square. So this is our answer. And then this one area, if p, open the bracket, x squared plus x, close the brackets, is equals to 9, has equal roots, but p is not 0, determine the value or the values of p. So what is important here, re nyaka the value of p, and then re find out the value of p if this has equal roots. So step number 1, ke tlo bea this equation in the standard form. So mo ke tlo re p times x squared, and then ka ba le px squared, and then ka p times x ka ba le px, and then ka jea -9 to the other side ya ba positive, and then equal to 0. And then from there you may realize already the value of a, it's p, give this 1, coefficient x squared, and then the value of b, it's also p, and then the value of c is positive 9, give this 1 ya tlhoka x. So from there nka shumisha discriminant, ka tseba gore the discriminant e lekana le b squared minus 4ac, and then the b is p minus 4, and then a is p, and then c it's 9. So from there e rela gore p squared ke na le p squared, and then from there this is -4, and then this is positive 9. So ke tlo re -4 times 9, and then it's -36, and then mo ke na le p e rela gore this is -36p, and then if this is p squared minus 36p, so this is the same as taking p and then ka ba le p and then minus 36, mo ke no factorize fela. So this is our discriminant, but now re nyaka go answer this question, e re find the values of p if the equation has equal roots. Ra tseba gore ge re ba le equal roots, this is the only time if the discriminant e lekana le 0, because if you remember, if the discriminant ya rena e ka lekana le 0, at some point ro ba le rational, ro ba le real, and then equal roots. So now we must find the value of p if this has equal roots. To have equal roots, the discriminant must be 0, and then in this case this is our discriminant. So mo ke tlo re p at p minus 36 and then equal to 0. Remember, this is just a discriminant. So from there can you find out the value of p. So I'll say p equal to 0 or p minus 36 equal to 0. So get this p and then equal to 0, and then p minus 36 equal to 0. So p equal to 0, and then as for this one, get p equal to positive 36. But really p is not 0. So in conclusion, therefore p is not equal to 0, but p equal to 36. So this is our solution. And then this one says For which values of k will the equation x squared plus x equal to k have no real roots? So re nyaka the values of k, but this equation, it must have no real roots. No real roots in non-real roots or imaginary roots. So that's why the only time rivalry non-real roots, it's only if delta ever less than 0, meaning ever negative. But first, let's find the delta, the discriminant. Ratobia this equation first in the standard form. So this is x squared plus x, and then to transpose a k, you change a sign, and then you have a negative. So from there, the value of a is 1, and then also the value of b, it's 1, and then c, it's negative k, because I know x. So from there, I should measure the discriminant. Delta elegantly b squared minus 4ac, and then from there we can substitute. B it's 1, and then minus 4, and then a is also 1, and then c it's negative k. So from there can only 1, and then negative 4 times positive 1 is just negative 4, and then negative 4 times negative k equally positive 4k. So this is our discriminant. But now we must find the value of k if this has non-real roots. I will say, for me to solve the value of k, the discriminant must be less than 0. And then this is our discriminant. 1 plus 4k is less than 0. So from there, we solve for k. 4k is less than negative 1. It will be a positive 1 to the other side. And then from there, because k, I will divide both sides ka 4. So k must be less than negative 1 over 4. So this is our solution. So finally the value of k. For me to have no real roots, the value of k must be less than negative 1 over 4. So this is our answer anyway. And then let's see this one. Given 3x squared plus kx minus 3x minus k equal to 0, for which values of k will the equation have real roots? First, try to this equation in order, because we have 4 terms. So we have 3x squared plus kx minus 3x minus k equal to 0. Because more than 4 terms, but here we common factor. X as a common factor. So re 3x squared, and then plus x, and then koshalaka k, and then minus 3, and then minus k equal to 0. Right, about x c, and then yellow is attached to x b. So I can say a 3, and then b elegantly k minus 3, and then c elegantly minus k. So from there, rakashumsha the discriminant, and then this is b squared minus 4ac, and then our b k minus 3, and then A is positive 3, and then C is minus K. So from there I resimplify. Moreover, K squared and then minus 6K plus 9 ke this part. Remember o ka dira in this way. Wa ba le K minus 3 and then wa ba le K minus 3. From there we multiply the brackets and then we group the like terms. So now I level this one. More than negative 4 times 3, and then negative 4 times 3 is negative 12, and then negative 12 times negative K rela robale a positive 12K. So from there I can group out like terms. Arnale K squared and then minus 6K plus 12K therefore positive 6K, and then plus 9. So this one is discriminant arena. And then now let's see here. For which values of K will the equation have real roots? If you remember on the summary, o ka lemoga gore ge le gore discriminant is greater than 0, re ba le real roots. And then again ge le gore discriminant e lekana le 0, still re sana le the real roots. So re la gore the symbol ya the real roots go tlo ngwala as greater or equal. This greater represent this one, and then equal represent this one. So re la gore for this one ke tlo re the discriminant is greater or equal to 0, and then from there ka substitute re la gore ke na le K squared plus 6K plus 9 is greater or equal to 0. So from there I factorize because ke na le quadratic. More global K and then mogi K. So this is plus, and then murabala 3, and then murabala 3. Because 3 times 3 you're for 9, and then the adder you're for 6. So from there the answer you're for K plus 3 is greater or equal to 0. Therefore K must be greater or equal to negative 3. So ginuja this 3 can share to the other side, and then you change a sign. Remember there is no need to get K plus 3 get greater or equal to 0 get K plus 3 because it's only the same thing. So this is our final answer. K must be greater or equal to negative 3. So now every time I deal with the real roots, this one. The discriminant must be greater or equal to 0. So that's it for this problem anyway. This one here, determine the value of P if 3 is a root of the equation. What is important here, question area, if 3 is a root, what we know the roots are the x values when the equation is 0. So here we are having the equation and then it's 0. So 3 is a root. It means 3 is the x value. So more than x squared plus px minus 3 equal to 0. And then because 3 is a root, x get substitute 3 because the roots are the x values when the equation is 0. So mogilo be 3 and then plus p at 3 minus 3 equal to 0. And then 3 squared it's 9, and then p times 3 is just 3p minus 3 equal to 0. And then from there, because I can solve for x, I add 9 and minus 3 because it like terms. So from here, can 3p 9 minus 3, it's positive 6. And then from there, 3p equal to negative 6, transpose 6, and then from there we can divide both sides ka coefficient ya p, and then re la 3 and 3 will cancel, then p equal to negative 2. So this is the answer. You'll find out the value of p. And then the question says, and then the question area, hence determine the other root. So re la gore ro lebella the answer that we got, and then ra tswela pele ka yona ra find the other root. So the other root ra tseba gore of course ba bolela ka x. So from there, because ke na le x squared, and then ke kry-ile value ya p which is negative 2, re la gore mo ke bona go p go be negative 2, and then ke na le negative 2x negative 3 equal to 0. Because question e re nyaka the other root, of course re la re nyaka value ya x. So from there ke tlo factorize and then ka find the values of x. So this is negative, and then this is plus, and then this is 3, and then this is positive 1. From there re la gore x minus 3 equal to 0, or x plus 1 equal to 0, and then from there solving for x, re la gore x equal to 3 or x equal to negative 1. So it really makes sense. Ra tseba gore ba file root ya mathomo gore it's positive 3, and then indeed here re na le positive 3, and then the other root re la gore ke x is equals to minus 1. So minus 1 is the other root. So re la gore re answerele this question. So that's it for this problem. This one e re the roots of the equation f at x equal to 0 are x equal to, you may realize or here we file a quadratic formula. Remember the roots of the equation are the values of x when the equation is 0, and then we can easily find the values of x by using a quadratic. So that is why we file x ilekana le this part. But what is important is this is a quadratic formula, and then a quadratic formula is in this way. And then on this formula b squared minus 4ac is the discriminant. And then because really this is a quadratic, this part is a discriminant. So now we need to find the value or the values of m for which the roots will be non-real. To have the non-real, the discriminant must be less than 0. And then for this problem, discriminant b squared minus 4ac, and then get this part. So ke tlo substitute ka yona ka re 16 minus 4m at minus m plus 5, and then less than 0. So from there nga multiply out a bracket, so generally 16 negative 4m times minus m generally positive 4m squared, and then negative 4m times positive 5 get negative 20m, and then less than 0. So ngengwala in the standard form ya ba 4m squared minus 20m plus 16 less than 0, because this is just a quadratic. And then from there I'm gonna divide both sides ka 4 to make things simple, because 4 is divisible by everything. Divide ka 4 o ka create fraction, so 4 will cancel 4, and then go shala ka m squared, and then negative 20 divided by 4, it's minus 5, and then you are minus 5m, and then 16 divided by 4, you are 4, and then less than 0. What is important gore o lemoga gore mo now o deala le quadratic inequality. This is quadratic and then this is inequality. So re la gore re tlo e solve re shumisha inequality. So step number 1 ke tlo factorize. Re la gore this is m, and then here is also m, and then mo re na le minus, and then re na le minus, and then the factors re na le 4 and 1. So this is the same as solving quadratic inequalities. Ge le gore you don't remember how to solve the inequalities, ke na le a full video mo ke dirago those kind of problems. So ka no lebelela yona first, and then wa tlo kgona go solve this problem. So mo ke tseba gore critical values tša rena m ke 4 and then m ke 1. So these are the critical values, and then from there o ka kgona bona gore equation ya rena e na le coefficient ya square term as positive. So e rela gore ge ke ya go ba le graph ya go ba something like, and then our critical values e rela gore mo ko ba le 1 and then mo ka ba le 4, and then because this equation because this inequality e less than 0, e rela gore less than 0 ra tseba gore ke below the x-axis, e rela gore you over here. So e rela gore in conclusion, solving this, e rela gore ko ba le 1 is less than m, and then m is less than 4. So this is the answer. Ke tseba gore the only challenge e ka no ba go solve this inequality, but you can check that video first. So this is our solution anyway. Re solvile this question ya gore determine the values of m. So m ya rena is between 1 and 4. So that's it for this problem, and that's it for this tutorial.